Good day guys, let's look at applications of parametric equations. The main application of parametric equations is always asking us to get the equation of a tangent to the curve. So our curve is defined as x equal to sec t and y equal to tan t. Just for you to have an idea of what is a tangent, if I have a curve, it might even be a circle. If you have any straight line that touches that curve, that the name of that straight line becomes a tangent. So in short, if you are told to get the equation of the tangent to a curve, what should come to your mind is that you are simply calculating the equation of a straight line. So I always prefer this format. You can always use the format y equal to mx plus c, you get to the same thing. So if I can get the equation of that straight line, then I'm done. So the main calculations we'll be doing here will be to calculate your y1, your m, and your x1. So your y1 and x1 are straightforward. You get them straight away from your x and your y. So these are your parametrics. When I'm ready to, that is the most important thing. So if I can go into my x, I replace t by pi over 4, that becomes x1. If I go into my y, I replace t by pi over 4, it becomes my y1. So that's how simple it is. So I will start by saying at t equal to pi over 4, my x will become the sec of pi over 4, and we know that in our calculator there is no sec, so you must understand it as 1 on cos pi over 4. If you punch that into your calculator, making sure that your calculator is in radians, that should give you the root of 2. So you see we are done with our x1. So if you go into your x equation, you replace t by pi over 4, it creates x1. As simple as that. Then I'll do the same thing for y1. So I will say at t equal to pi over 4, it means my y, which was supposed to be tan t, will be called y1, and I will say it's tan of pi over 4. If your calculator is in radians, then the tan of pi over 4 will give you a 1. So you are done with y1 and you are done with x1. Now to get m, which stands for the gradient, you must look for dy dx. So since the gradient is changing y and changing x. So to get the gradient, you know how we do it with parametric equations. Or to get dy dx, I was saying if x is equal to sec t, then I need to look for dx over dt. So dx over dt, the derivative is sec t tan t. If you are using your formula sheet for mathematics, that formula is on page number 2. Then if y is equal to tan t, this means that dy over dt should be equal to tan square, sorry, not tan, if you differentiate tan, that should be giving you sec square t. So the derivative of tan t should be sec square t. So if you now combine this, as we've been doing, you will get your dy over dx, which is the derivative of y with respect to t, divided by the derivative of x with respect to t. That's how we get the first derivative from parametrics. So dy dt is sec square t divided by sec t tan t, which is your dx dt. So you will always hear me tell you that once you get dy dx, do your best to simplify it to the lowest level. So here, sec will reduce that so that you are left with sec t over tan t. But that is still not the lowest level, because the lowest level in trigonometry is when I start seeing sine and cos. So we already saw that sec means 1 over cos. So sec t is 1 over cos t. I'm dividing it by tan t, which itself is sine t over cos t. So if I now change division to multiplication, then this will become cos over sine, and cos will take care of itself, and my answer will be 1 over sine t. So that's my dy dx. So at t equal to pi over 4, this dy dx is supposed to become the gradient. So if I replace t here by pi over 4, this will become the gradient. I'll get the sine 1 over sine pi over 4. If your calculator is still in radians, your answer will be a simple root. So up to so far, we have succeeded to get y1, we've got x1, we've got m. So our x1 is root 2, our y1 is 1, our m is root 2. So we'll then transfer that information into the equation of a straight line. So therefore, I'm getting y minus y1, our y1 is a 1, is equal to our m, which is a root 2 into x minus x1, our x1 is another root 2, then if I open the bracket, I'll get y minus 1 is equal to root 2x minus 2, since root 2 times root 2 is a 2, then this one will come to me 2 as a like term, and I'll get 1 minus 2, and that shows that the equation of the tangent to the curve is root 2x minus 1. So guys, that is what we do for that one. So calculating the equation of the tangent to the curve is that simple. So let's look at another problem on the same exercise. We need the equation of the tangent to the curve. Our curve is defined parametrically as y equal to 3t squared and x equal to 3t minus t cubed and t equal to 2. So our starting point is capturing the equation of the straight line that we want to use, since we are now aware that a tangent to a curve is just a straight line that touches a curve. So from here, we go to our y1. So to get y1, I capture y and replace t by 2. So I will say at t equal to 2, this means that my y1 will be 3 into 2 squared. 2 squared is 4. 4 times 3 is 12. That's my y1. Then at t again equal to 2, this will mean that my x1 means I will capture my x and I will replace t by 2. So 3 times 2 is 6. 2 cubed is 8. 6 minus 8 is a negative 2. So I'm done with x1 and y1. It's now time to look for m. So if x is equal to 3t minus t cubed, this means that dx over dt is equal to 3 minus 3t squared. That's my derivative. And if y is equal to 3t squared, this means that dy over dt is 6t. So since I'm done with those two derivatives, I can now look for dy over dx, which is the derivative of y with respect to t divided by the derivative of x with respect to t, and that gives me 6t. I'm taking the derivative of y, which is 6t, I divide by 3 minus 3t squared. So that's my dy dx. Then at t equal to 2, this first derivative will automatically become our gradient. So at 2, I will take 6 into 2 divided by 3 minus 3 into 2 squared. So 6 times 2 you are at 12. 3 squared, 2 squared is a 4 times 3 is a 12. 3 minus 12 should be a negative 9. I guess so. Yeah, so negative 9 is the same thing as negative 4 over 3, since 3 will go there 3 times and then 4 times. So that is our gradient. We now know our gradient m to be negative 4 over 3. Our y1 is 12, our x1 is negative 2. We then transfer that information into the equation of a straight line, which will tell me that I'll get y minus y1. y1 is 12 is equal to m. My m is negative 4 over 3 into x minus x1. My x1 is a negative 2. So this means you get y minus 12 is equal to negative 4 over 3 into x plus 2. If you you open your bracket, y minus 12 will be negative 4 over 3x, then minus 8 over 3, since negative 4 over 3 times 2 is 8 over 3. So 12 will then cross over. So if 12 crosses over, it becomes negative 12 crosses over, it becomes positive. So we now need to take 12 minus 8 over 3. 12 minus 8 over 3. That gives us 28 over 3 being positive. So we get plus 28 over 3. So guys, this is how we get the equation of a tangent to a curve. Thank you very much.